Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The Bat's Friend by Nicole Lamanna. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We also have dynamic fog, where the grid is covered in fog, and placing a correct digit will clear the fog from that cell and potentially from other cells somewhere in the grid. No guessing is required to progress. So I actually prefer this version of dynamic fog where you know you're clear. If you place the correct digit, you'll clear the fog in that cell. But you're not guaranteed to clear it as fog in any other cell, but you can. It could potentially do that. And that's how dynamic fog works. We also have cages, where the sum of the digits inside each cage is equal to the small number in the top left corner. So, for example, these 3 digits must add up to 6. Well, that should tell you something because it's a pretty big constraint there, but we'll leave that to the solving. We have cells with a filled gray square, I can't speak, must contain an even digit. So this has to be an even digit here. And cells filled with a cells with a filled gray circle must contain an odd digit. So cells with a gray circle equivalent of this must be odd. We have a light orange entropic line, where every set of 3 consecutive numbers must include a low digit 1 through 3, a medium digit 4 through 6, and a high digit 7 through 9. So, for example, if you had an entropic line here, a valid entropic line would be something like, say, 2, 8, and 5. Because we have in 3 cells along, 3 consecutive cells along this entropic line. You have 1 digit that's low, 1 digit that's medium, and 1 digit that's high. Say this line extended here. A valid number here would then be 1, 2, or 3. Because along this set of 3 consecutive digits, along this entropic line, you already have a high digit and you have a medium digit. So this must be a low digit in that case. And it could be 1, 2, or 3. So that's an example of how entropic lines work. We also have quadruple circles, where digits inside a white circle, so the white circles are going to be on the vertices of these cells. So like around these cells, this would be the vertex here, and there would be like a white circle surrounding that. So, and it's pretty big. So there are digits inside a white circle. So say there was a white circle around these 4 cells, must appear at least in at least one of the 4 cells surrounding that circle. So say there was a circle here in this vertex. Then any digits that appear there must appear at least once in the 4 surrounding cells around that circle. And we don't have an example, unfortunately, but it should be fairly obvious what that means. We also have Kropke dots, where cells separated by a black dot must have the 1:2 ratio. So, for example, if this were, say, a 2 here, this would have to be 1 or 4 to maintain the 1:2 ratio between them. And that's an example of how Kropke dots work. And finally, we have pink Renban lines, where they must contain a non-repeating set of consecutive digits in any order. So say you had like a Renban line here. A valid Renban could be something like 6, 8, 4, 5, and 7. Since that forms a consecutive set of digits, 4, 5, 6, 7, 8. And they can be in any order, so that's why this is fine. What you could not have is something like, I don't know, 67457 because you have a repeat here. And you can't have something like 69457 because this does not, 45679 is not consecutive. So those are examples of how rim-band lines work and they don't work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, as I refer to it in the rules, these three digits add up to 6. So they have to be 1, 2, and 3 because those are the only three unique digits, which they all are because they're in the same box, that can ever add up to 6. And 2 has to be the even digit, so this is 2. 1 can only be in a 1 to 2 ratio with 2, and we already have a 2 in this box, so this can't be 1. This is 3, and this is 1. 3 is in a 1 to 2 ratio with 6. Okay, so this is an even digit. In this box, or in this quad specifically, you have to have 2, 3, 4, and 5 in the surrounding 4 cells. Since that's the case, this forms a 2, 3, 4, 5 quadruplet, which eliminates 2, 3, 4, 5 in the rest of the box. So this now has to be 1, 6, 7, 8, 9. Now, every 3 cells on an entropic line have to be 1 low, 1 middle, and 1 high. If this were low, that would be, if this were low or middle, these would have to be the other sets, and then this would also have to be low and middle. Because on any line that has constraint dealing with 3 consecutive cells in them, these 2 digits are always going to remain the same. So whatever set this is part of, it has to be the same set as this, right? Because anything that's 3 away. So this is the same set as that, right? So this cannot be 1 or 6, this because of the 1, 6 in the row. So this is 7, 8, 9, which we'll mark as a high. Therefore, these must be medium and low. Therefore, this must be high here. So this cannot be 1 or 6. This is medium and low in some order. So it has to be a 1, 6 pair because those are the only mediums and lows left in the box. So this can't be 1 or 6 and it's a high. So this must be medium or low. We don't know which. This is medium or low. This must be medium or low here because that's going to continue on there. Where are the 1 and 6 in row 3? They cannot be here because of 1, 6 in the boxes. This 1, 6 and this 1, 6 pair here. So they have to be in these 3 cells. So we're guaranteed a 1 or 6 in one of those 3 cells. They could be in both of these. So in that case, but this, we know this is 1 through 6 here, and this is 1 through 6 here. Remaining digits in this upper left-hand box have to be 4, 5, 7, 8, 9. Okay. Remaining digits in row 1 are also 4, 5, 7, 8, 9. Okay. We know there's a 5 somewhere in these 3 cells. We also know there's a 6 somewhere in one of these 3 cells. If either of these are 5, this cannot be a 5 because they're in the same row. If this is a 5, then this also can't be a 5 because this would have to be a middle digit, which makes that a low digit. So you have the same logic there for 6 also, right? If 6 is one of these two, this can't be 6. If 6 is here, this can't be 6 because it would have to be a low digit because this is middle. So this cannot ever be 5 or 6 here. It's 1 through 4. Okay? Hmm. What other information do we have here? Okay, dynamic fog of war, cages, we don't have anything there. Gray cell, we don't know if what this is. This doesn't, I think, have a cell. Nope, no cell. Okay. Entropic lines. Oh, this has to be an even digit because it's a square. So this is 6, which makes this 1. So this cannot be low, it's middle. This can't be middle. Therefore, this is middle here to form a set here, and this must be non-middle. It's low. So this cannot be. This is 1, 2, or 3. This has to be 4, 5, or 6. This can't be 1 here. 1 and 6 have to surround this quad here. So that means this. Sorry, 1, 2, 3, and 6 have to surround this quad. 1 and 6 can only be here, so this becomes a 1, 6 pair, and this is a 2, 3 pair, which eliminates 2 and 3 in the rest of the row. This can't be 2 or 3. This becomes a 4, 5 pair, which eliminates 4 and 5 in the rest of the row and the box. So this can't be 4, 5. This can't be 4, 5. This can't be 6. So it's 4 or 5 here. This can't be 4, 5. This has to be 7, 8, or 9 here, which is only consecutive with 7, 8, or 9 out of the 4, 5, 7, 8, and 9. And this is in a 1 to 2 ratio. 7 and 9 can never be in a 1 to 2 ratio with another digit. If you have them, you get 3.5 and 4.5, which are not digits. If you double them, you get 14 or 18, which are not digits. So this must be an 8, which is in a 1 to 2 ratio with 4. That means this can't be 4. This is 5. So this can't be 4 or 5 here. This can't be 8. This can't be 8. So these are all high digits here. This can't be 8. This must be a medium digit. These are low. So we're going to make these low. These are low. These are low. These are middle. So this must be high. And the last remaining digit in row 1 is a middle, and so must be 5. None of these can be 5 here. Around this box, we have to have 5, 6, 7, or 8. So this cannot be 9, because all 4 of the unique digits have to be in the 4 cell surrounding. So this must be 6, 7, or 8 here. This cannot be 8 because of 8 in the column. Therefore, one of these is 8, so this cannot be 8 here. We have a 7, 9, 7, 9 pair in row 2, which eliminates 7 and 9 in the rest of the row. This cannot be 7 or 9. This must be 8, which eliminates 8 here. So this is a 4, 7, 9 triplet. This 4, 7, 9 triplet eliminates 7 here. So this must be 8 here. This cannot be 8 here. This is medium, low, so this is high. That makes this medium, and this must be low. So this cannot be 2, because, and surrounding this quad has to be 2, 4, and 5. So this can't be 4, 5, therefore the only medium digit left is 6. So that's 6, which makes this 1, which makes that 6. 6 eliminates 6 here, so it's 7 and 6 there. So this is medium, this is high. This 7 eliminates 7 here, so this is 9 and 7. This 7 eliminates 7 here, so it's 9 and 7. This has to be 1 and 3 as a pair, because 2 cannot be, must be in the cell surrounding this quad, so it can't be 2. This is 8 or 9 here. We have 2, 4, 5, and 8 or 9 as possibilities because of the 1, 3 pair in the box. This can't be 8 or 9. This can't be 5, so this becomes a 2, 4 pair here, which eliminates 2 and 4 in the rest of the box. So this is guaranteed to be 5 here. This is middle. We have low here. This is in a 1 to 2 ratio. Well, 7 and 9 again can't be in a 1 to 2 ratio with another digit. So this is 4, which makes this a 2 because we have an 8 here. So this is medium, which makes these both high. No 4 here. This is low as a 2. This is an even digit because it's a square, and it cannot be 8, 2, or 4 because of the 8 and the 2, 4 pair in the column. So this is a 6 and is a middle digit. We have 3 high digits already accounted for in column 7, and 3 middle digits, the 5, the 4, and the 6 accounted for in column 7. So this must be 2 low digits here. And these are 2 digits adding up to 15. We don't have a 6 available, so this has to be 7 and 8 specifically. Again, 7 can't be next to a black crop key dot because it can't be in a 1 to 2 ratio with another digit. So this is 8, this is 7. 8 is in a 1 to 2 ratio with 4. So this is 4 as this 1 eliminates 1 here. So this is 3, which makes this 1. This 8 here eliminates 8 as a possibility here, so this becomes a 5, 9 pair, which eliminates 5 and 9 in the rest of the box, so this can't be 9, that's 8. 3 eliminates 3 here, so this is 2, which makes this 3. What is the last remaining digit in column 8? It's 2, so this is 2 and a low. This is a 1, 3 pair, and this becomes a 5, 9 pair here in column 9. Okay, this is an odd digit here, and it must be in a 1 to 2 ratio with another digit. It can't be 1, 2. Obviously, 4 and 8 doesn't work, so this must be 3 and 6. So this is 3. This is a low digit. This is medium. 3 eliminates 3 here, so this is 1 and 3. Where is the 6 in this left central box? Cannot be here, cannot be here, can't be any of these. So this must be a 6 here, which is in a 1 to 2 ratio with 3. Ooh, the bat's friend. Why? It's a ghost? I don't know. This is 3 and 6. This is entropic line, so we're going to have lows and highs also there. This is a Renban. Okay. So we know on this entropic line, in these 3 consecutive cells, there must be a low digit. And we already have 2 and 3 here, so the low digit must be 1. So the low digit has to be here. Therefore, we cannot have a low digit in the rest of the box because we already have 2, 3, and 1 accounted for. So this cannot be low. Where is the last low? In column 1, it has to be here. So this is low and it's a 1. These both have to be high because those are the only remaining cells possible. And they have to be 7 and 9 specifically. Well, there again, on this 3-cell part of the entropic line, we have to have a high digit. And it cannot be 7 or 9. It has to be 8. It cannot be 8 here. So therefore, it must be one of these 2 cells. Therefore, this is guaranteed to be a middle cell, a middle digit, which means that's a middle digit. Every 3rd digit on this cell, again, is a middle digit because of the way 3-cell lines with restrictions occur. So this must be a middle digit, every 3rd one. 1, 2, 3, so this is a middle digit. Okay, this has to be a 1, 8 pair here. This has to be a middle digit because that's the only digit remaining in this left central box. This is a blue-red pair. We don't know which one's which. This is also a blue-red pair. And this is also a blue-red pair. We have a blue-red pair here, and they're 3 and 9. So this cannot be 9 here, so it must be 3, which means this is blue, and this is red, and this is a 9. Therefore, this must be non-blue, because we already have blue and a green here. This must be blue, because we have red, green here. So since this is red, this is not red, that's blue. Not blue, not red. Not blue, not red. Not blue, not red. Okay. This has to be the last low digit, so this is 3. This makes this 2, which means this can't be 2. That's 4 and 2 there. This has to be 8 as a high digit, and this is 1. So this is a 1 to 2 ratio. Without 2, without 3 and 6, it has to be 4 and 8. This can't be 4, so this must be 4 here, and this must be 8. This is a middle digit, and this is a high digit here. That means this must be a 5 as the last middle digit in that box, so that makes this 9 and 5. So now we have, this is low. We actually don't care about the low, mediums, and highs anymore, because we have all the entropic line filled out. This has to be a 4-5 pair. Well, maybe we do. We have 3 lows already in column 3. We have 3 middles in column 3, so these must be high. So this is high. We have 3 highs in row 8, and this can't be low either, so this must be middle. We have 3 middles in column 5. So this can't be middle here, and it can't be low because that would be too large for this Renban line to be consecutive. So this has to be high. 3 eliminates 3 here, so this is 2, which makes that 3. This can't be 1 or 3, so this must be 2. This has to be 2 here because of the 1-3 pair in the box. Okay, so maybe we do need still all the coloring. So this is middle, middle. That makes this high. This has to be high. No, it can't be high. It's low. Because we have 3 highs already in row 5. That makes this a high here. 9 eliminates 9 here. So this is 7. This is 9. That makes this a 7 here. This is a 1. In column 4, we have 3 lows and 3 highs, so this must be middle here. Since these are 3 middles, we have 3 middles in row 8, 7, so this can't be middle, this is high, which makes this middle here. So this is a 9, this is 5. This must be a 7-8 pair to add with 6, so this is 6. This can't be 8, so it's 7, which makes this 8. 5 and 6 are here, so that forces this to be 4. That forces this to be 5, that 4, that 5. So 4 eliminates 4 here, so it's 5 and 4. This must be a low digit. That's the only digit remaining. Column 5, so this is 1. This is 8 or 9. This can't be 8 because of 8 in the row, so it's 9, which makes this 8. 5 eliminates 5 here, so it's 4 and 5. This can't be 9, so this is 7, which makes this 9, which makes this 7, and this 9. Boo! You found the bat's friend. I guess we did. Why is that? Why is a ghost a bat's friend? I don't know. Oh, I guess it's because of it's Halloween, maybe. So this is yeah, I'm doing this well after Halloween, but a lot of these puzzles are still made in October. So it's probably referencing Halloween here. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.